I'm going to use them to first thank the organizers for this opportunity to speak today, and hopefully I'll manage to convince you that there's a major flaw in the way that we as a community tackle a fundamental question in microbiome research. And next I'll present to you LAMPP, our new live benchmark aiming to solve this, and ask you to join us in the effort of making things a bit better. So let's start. So predicting host phenotypes for metagenomics data or diagnosing human disease from metagenomics data is a fundamental question in our field. It is usually done by training some machine learning algorithm on a data set of metagenomic samples labeled case versus control. And this algorithm, if done properly, is later evaluated on some unseen data. If we look at the number of publications on host phenotype predictions per year, we can see the numbers just keep going up. And the interesting thing about it, it's not only just that people collect more data sets and use them to study host phenotype prediction, it's that, let's call them people who code or computational biologists, develop many tools for this exact task. I counted dozens of tools and roughly 40 new tools from 2025 alone. In the meanwhile, researchers collecting microbiome data, so people with data, simply use random forest. There's nothing wrong about using random forest, but it does make me wonder, can we push forward the state of the art in our field? Is one of these tools even worth a try? And this answer should be easy if we just do some benchmarking. So briefly, I'll say that by benchmarking, I mean comparing prediction tools across a standardized set of prediction tasks. Today, we can find two types of benchmarks for metagenomics-based phenotype prediction. The first is self-benchmarking. So imagine I've just built a brand new tool. I'm naturally going to compare it to a couple of other baselines on a couple of tasks. The flaw of this type of benchmarking is that it is usually very limited, the number of tools and tasks considered. And unfortunately, if I'm the person developing the tool, I'm probably gonna outperform the baselines. Then we have another type of benchmarks, which are independent static benchmarks. And these are where a separate team of researchers take a bunch of tools and compare them over a bunch of tasks. These are much, much better, but unfortunately, they still cannot cover all tools, right? Who's the PhD student who's gonna run dozens or even more than dozens of tools in their benchmark? And moreover, they're static. So by design, once these papers are published, they're already getting outdated. I would like to suggest a third way of benchmarking, and I'd like to offer independent live benchmarking. So this is a very common practice in other fields of computer science, and I personally think that it was one of the things that drove the major change or the major explosion of deep learning methods in NLP, natural language processing, and computer vision. And the cool thing about it is that it allows democratization of benchmarking. So people put up the benchmark, and tool developers take responsibility over benchmarking their tools by submitting their tool for the benchmark. And the benchmark this way still stays unbiased. So this is a great segue for introducing our benchmark, LAMPP, Live Assessment of Metagenomic Tools for Host Phenotype Prediction. Briefly, I'll say that it's made out of 6 tasks. Each task is practically metagenomics data split into labeled training set and unlabeled test set. And the data is available both as simple relative abundance tables as well as a raw FASTQ file. And it tries to capture the challenges of this data, of microbiome data. So longitudinality, different phenotypes, size, etc. Next, we picked 9 baseline tools, which again try to capture a variety of tools. So classic versus deep learning, off-the-shelf versus microbiome tools, different data pre-processing steps. And I won't tell you which tool did best, but I will try to encourage you to go to our website and check which tool is on the top of the leaderboard at the moment. And moreover, I'll try to convince you to submit your own tool. When I say your own tool, it could be a tool that you have developed, but it can also be the prediction pipeline that you use in the lab and you just want to know how well it is, how well it performs in comparison to other tools. It's very simple. You go to the website, you download the prediction tasks, you predict the probability, submit the tools, predictions, and you see the tool on the leaderboard. Right before I need to finish, I'd like to thank my supervisor and our collaborators, Jay Soong from Mayo Clinic, Francesco Asnical, and Nicola Segata from the University of Trento. I'm happy to take questions. Thank you.